Hey guys, welcome back to Road to USACO Gold. This is episode 2. Today we're going to be looking at the 2018 January contest. We're going to be doing the bronze division. It's going to be great. Let's jump in. Alright, let's click the 2018 January contest. Let's scroll down. Let's click the first problem for the bronze division, or blocks billboard 2. So I've done this one before. It's pretty easy. I'm just going to show it to you guys. So let's start reading. Bessie the cow used to have such a nice view from her barn, looking across the road at a set of two billboards advertising delicious looking cow feed. Unfortunately, one of these billboards has recently been updated so it now advertises Farmer Larry's lawnmowers. Bessie is not a fan of lawnmowers since their only purpose, as far as she can tell, is cutting back the grass in her field that she finds so tasty. If you haven't noticed, much of Bessie's thought process revolves around food. So we don't learn anything from this paragraph, so let's just keep reading. Fortunately, the remaining cow feed billboard is situated in front of the lawnmower billboard, potentially obscuring it. Bessie, determined to remove the offensive lawnmower billboard completely from her view, hatches a risky plan. She plans to steal a large rectangular tarp from the barn and sneak out late at night to cover the remaining portion of the lawnmower billboard so that she can no longer see any part of it. Given the locations of the two billboards, please help Bessie compute the minimum area of the tarp she will need. Since the only tarps available in the barn are rectangular in size, Bessie observes she may conceivably need a tarp whose area is slightly larger than the exposed area of the lawnmower billboard, as illustrated in the example below. The tarp may be only placed such that its sides are parallel to those of the other billboards, i.e. it cannot be tilted. Alright, let's just map this out real quick so we know, or in general, what we're supposed to do. So they talk about two rectangular billboards, so let's just draw two rectangles using our polygon tool. So let's just draw one here, and let's just say this is a lawnmower billboard. Let's draw another one and say that this is the cow feed billboard. So in this case, the cow feed billboard is in front, so the lawnmower billboard is cut off by about 3 units here, 3 square units. And Bessie wants to cover the lawnmower billboard entirely, but she cannot have a tarp that's like in the shape of like this like shoe or boot thing. So she needs a tarp as big as the entire billboard itself. So A, B, C, D. So then she'll just have to get a tarp that's 2 by 1, 2, 3, 4, 5 long. So this answer would be 10. Let's look at the input format. So let's get here. The first line of input contains 4 space-separated integers: x1, y1, x2, y2, where x1 and y1 and x2 and y2 are the coordinates of the lower left and upper right corners of the lawnmower billboard in Bessie's 2D view. So what they mean by this is, let's just delete this real quick. And what she mean by what they mean by it is, like, if we have this rectangle, 1, 1 would be x1, y1, as that's the lower left corner, and 6, 3 would be x2, y2, as that's the upper right corner. And as you can see, these cohesively form a rectangle through their coordinates. Let's delete this and continue reading. The next line contains 4 more integers, similarly specifying the lower left and upper right corners of the cow feed billboard. The cow feed billboard may obscure all, some, or none of the lawnmower billboard. All coordinates are in the range -1,000 to positive 1,000. Alright, so they give us the coordinates of 2 rectangles, and we need to find the minimum area of the tarp Bessie needs to use to cover part of the lawnmower billboard so that it becomes completely obscured. So, sample input, let's just plug in the sample input into our graph. So the first point is 2, 1. Let's just make 2 rectangles using their points. Alright, let's look at the second point, and 7, 4. So 7, 4 is right here. So it's going to be 7, so it's going to be at 7. It's going to be at 4. And let's just complete the rectangle from there. And the second rectangle starts at 5, 1 and ends at 10, 3. So we're going to go to 5, 1, which is right here. Or 5, -1, sorry. 5, -1, which is right here. And 10, we're going to go to 10. And we're going to go to 3. Alright, so this one is the cow feed billboard, and this one is the lawnmower billboard. As you can see, the lawnmower billboard is obscured by the cow feed billboard by about like a small square, and Bessie wants to completely cover it. However, she cannot have a tarp that's shaped like this, or like some upside down shoe or boot. So then, in that case, she needs a tarp as big as the original billboard, which is in this case 3 by 5 for 15. And that's exactly what the answer is. So now we need to work out all the possible cases in which the billboard can possibly obscure all, some, or none of the lawnmower billboard. So in this case, if we move this rectangle, sorry about that. If we move this rectangle, let's just say it's over here. In this case, Bessie would still need to use all of the tarp to cover all of the billboard's area. So in this case, the tarp would be as large as the billboard. If the billboard is obscured by one corner, if one corner is obscured by the cow feed billboard, Bessie would still need to use the thing as big as the tarp, or as big as the billboard. However, if it's completely covered by, let's just say this cow feed billboard is larger, then Bessie would need 0, as it's already completely covered by the cow feed billboard. Our last case is if the cow feed billboard covers 2 corners of the lawnmower billboard. In that case, Bessie would only need this area. So again, we have 3 cases. So let's just write it out. So we're going to go to our text, and we're going to put some here. So our first case is that the cow feed billboard covers none of the lawnmower billboard. Our second case is if the cow feed billboard covers one corner of the lawnmower billboard. And our third and final case is if the cow feed billboard covers 2 corners. Oh, sorry, our third, not our final case, but we have 4 cases. Covers 2 corners of the lawnmower billboard. It's always good to map out your ideas like this. And our fourth and final case would be the cow feed billboard covers all of the lawnmower billboard. Alright, now that we have our basic thinking down, we can start coding. Alright guys, welcome back to my IDE IntelliJ. Today we're just going to quickly code this out. So back to our problem. We can see that it's again separated tokens and 2 separate lines. So we have to read them into variables again using string tokenizer like last episode. So let's just do that real quick. So just like last time, we do string tokenizer st equals new string tokenizer br.readline. As you can see, I've already put my BufferedReader and PrintWriter functions up there. You can copy them every time from a previous project. I forgot to put this into the description last time. I will probably put this in the description this video. So let's just do string tokenizer real quick. and read in the variables, or read in the input and put them into variables. So br.readline, as always remember, the L is capitalized, and when we import it, and let's declare the variables. So as you know, they mentioned the first one is in x1, so let's just call it that, and it's integer.parseInt to convert it to an integer, as it's written as a string. We're going to do br.readline. Oh, sorry, I shouldn't have quit quotes. So it's st.next token that harnesses the br, and we can just copy and paste this. Oops, sorry about that. And then let's just change the in x1. So it's in x1. Next one is in y1. Then int x2. Sorry about that. And then int y2. Alright, this concludes our reading and input for this line. So we have to jump to the next line. On last episode, the input was only one line, so we didn't have to redeclare our string tokenizer. But this one has 2 lines of input, so in this case, we have to redeclare our string tokenizer by saying st equals new string tokenizer br.readline. This allows us to jump to the next line and start tokenizing the next tokens in the next line. Alright, now we can just simply copy and paste this again and change the values. So this is x3 and this is y3. This is x4. And finally this is y4. Alright, now that we have read in our input and plugged it into some variables, we can start coding in our 4 cases mentioned before. So the easiest of these 4 cases would be the 4th one, or the cow feed billboard covers all of the lawnmower billboard. This is the lawnmower billboard, and this is the cow feed billboard. So the 4th case is only satisfied if this billboard is the same area as this one, or it's larger than it. So how do we know that it's larger or the same? So we can use these 2 points that define the rectangle. So as you can see, this point's x value is always going to be greater than this point's x value, and this point's x value is always going to be less than this point's x value. So they're exactly inverse. Same goes for the y values. This point's y value is always going to be greater than this point's y value, and this point's y value is always going to be less than this point's y value. So keeping that in mind, we can code that our first case. Alright, so we just do an if statement real quick, as such. So it's going to go like this. If x1, so we're checking, so going back to this, we need to know what points. So in this case, this would be x1, and this would be x3, this would be x2, and this would be x4, and then we just follow that with the y's. So it's going to be if x1 is greater than equal to x3, and we're going to add an operator here. So this says and x2 is less than or equal to x4. So this compares our x values. We're going to put that in parentheses. So what this is saying, this is saying that if this x value is greater than this x value and this x value is less than this x value, then it's contained within the x values. That means if the y values are satisfied as well, it's going to be either the same or completely covered. It's going to be completely covered either way, whether it's the same or it's greater than. So we're going to do the y values now. So it's going to be y1 is less than or equal to y3, and y2 is less than or equal to y4. So we're just going to put this in parentheses as well. Add a semicolon or bracket. In this case, like we said before, it's going to print 0 as it's completely covered and Bessie doesn't need to do anything. Therefore, the tarp would be 0 as nothing is there. And we do that, and then we return or print out 0 using the our PW function, and then we would close it as that's the end of the code if that happens, and we close BR as well. Now we code our let's just code the other cases. So all of these, the rest of the 3 cases involve whether a corner is covered, none of the corners are covered, or one corner is covered. So in this case, we need to make a corner function or a covered function that allows us to see if one corner is covered by a rectangle. So in this case, let's write out the function for whether a corner is covered by one rectangle. So we're going to write a new class. It's going to be called covered. So let's just call it public static boolean, as it's going to say, is this covered, true or false? And let's just do this. We're going to do, our parameters are going to be the coordinates of the point or the corner, and the other coordinates are going to be the coordinates, the 2 points that define a rectangle. So in y2, in x2, into y2, into x3, and into y3. So how do we know that this point is covered? Oh, sorry, we have to name it. So how do we know that point x1, y1 is covered by x2, y2? Well, it's essentially the same logic as we did with our whether it's completely covered by the cow feed billboard. So we do this. We do if x1 is less than or equal to x2 and x1 is less than or equal to x3. Basically, this is saying if it's within the x values of our rectangle. If we go back here, if you don't really understand that, let's just say we're comparing C to this rectangle. If C is within both of its x values, then of course it's going to be within the rectangle. Now we just need to check the y values. See, if we don't check the y values, then C could be here and it would be still within the x values. So in this case, we need to check the y, if it's within the x values, and if it's within the y values or the length. So let's go back to our IDE, and then we keep on check this. We check if it's within the x values of the rectangle. Now we need to check the y values. So it's y1 is greater than equal to y2, and y1 is less than or equal to y3. It's very simple. It's very concise and clear. It's just simple logic. That's what we're doing here. Now, if this is true, then we return true, as it's in the rectangle, and else or we don't need to put an else statement. We can just go return false. That's just going to be the default return statement. Alright, now we just need to declare one more class. We need to, two more classes actually. So we don't want to type out the formula for the area of the rectangle given 2 points. So I'm going to make a class called public static int area of rectangle, or area of rec, and it just takes 2 points of a rectangle, like as we mentioned before. So it's just going to be an x1 int y1 int x2 int y2, if you're confused on what these are, these have no correlation with what we read in earlier. These are just defining parameters as we can, like, for example, if we want to find the area of a rectangle at, let's just say it's 1, the first point is 1, 2, and the other point is 3, 4. These are would just be these values that we call. I just like x1, y1, x2, y2 because it's really simple and easy to understand for me. If it doesn't really click to you, then you can perhaps change the variable names. But I'm just using this because it's easily organized, and we know exactly what they are. All right, so area of rectangle, it's going to be a positive difference between. So area of rectangle is just length times width, so it's just going to be the difference between x values and the difference between the y values. But keep in mind that these are positive differences. So it's just going to be length times width, and we're going to replace L with x minus x2 minus x1. I'm going to replace W with y2 minus y1. Alright, so we're just going to return this. And yeah, it works. Alright, now we just declare one final class. If this is getting tiring, don't worry. I'm here to help you through it. So our final class would be, we're going to find the visible area between two rectangles. Alright, to clarify, so if two corners are covered by the cow feed billboard, then we need to find the remaining area of this lawnmower billboard. As you can see, some of it is overlapped with the cow feed billboard and therefore covered by the cow feed billboard. But we still have some area we need to cover with the tarp, and it is a rectangle, so Bessie can use the tarp that is smaller than the original area of the lawnmower billboard. So we need to find the algorithm to calculate the overlapped region, and we need to use this region to subtract from this. Well, if you notice, this point, the bottom left corner of this overlap region is either going to be the x value of E or sometimes A. Well, we can always find that if you see this corner is always going to be the greater of A and E. So if we plug that into our original thing, this would be x1 and this would be x3. So we would do math.max x1 and x3. Same applies to, let's just say, x2 and x4. However, it would be the opposite, since we would look for the minimum in that case. If you look at x2 and x4, in this case, x2 is being used, but when it is put over here, x4 is being used. Like so. In this case, we need to find the maximum of x1 and x3, as well as the minimum of x2 and x4. As for the y values, it's basically the same. You need to find the maximum of y1 and y3, and the minimum of y2 and y4. So we're going to call this class visible area. So let's do it. So it's going to be a static int visible area, and our parameters are going to be int x1, int x1, int y1. This is just going to describe our first rectangle, and x2, int y2. So this is just going to be the first rectangle, or this is just going to be the lawnmower billboard. There's so many billboards, man. It's kind of hard to talk about them all. And x3 and y3. Sorry about that. Int. Oh, sorry. Why are you red? Oh, sorry. I forgot to put a comma there. Int x4. Sorry guys, I have a new keyboard here. I've been adjusting. Please excuse my typos. And y4. So these points describe the first 4 points describe our first rectangle, and our second 4 points describe our second rectangle. Alright, since we're going to take the overlap region and subtract it from our original area of the lawnmower billboard, we need to declare a variable for our lawnmower billboard area. So let's just do visible area. So this is just going to be defined as our billboard area first, and then we're going to subtract something from it. So visible area equals area of rectangle. The thing, we can use this since we just already defined it. So area of rectangle, x1, y1, x2, y2. So we're just using the 2 points that describe the rectangle of the lawnmower billboard. And we're going to keep going. So we want to define our left boundary. So we described it as the maximum of x1 and x3. So we're just going to call it left bound. And it's going to be equal to math.max x1 and x3. So this will ensure that our corner will be the one that would define our overlap region. Same goes for the right bound, which is math.min x2 and x4. And now we're going to do the y. So it's int bottom bound, as it's on the bottom, equals math.max. So if you don't know why I call it bottom, it just defines this bottom y value of the overlapped region. So let's keep going. Math.max y1, y3, and int top bound equals math.min y2, y4. Pay attention to the order or the pattern. It's max and min, max and min. Alright, now that we have our values defined using our parameters, we need to find out if they actually match. For example, if the leftmost bound is greater than the rightmost bound, let's see what happens if in that case. Sorry about that. Let's just say that this bound is greater than our right bound. Then that wouldn't make it. Then it would just be inside the square. We have to make sure that there's an adequate region for our overlap to be taken area of. So let's go back to our code, and we need to declare an if statement. Let's say if left bound is less than right bound, and our bottom bound is less than our top bound, as you cannot have it. You can't have your bottom bound greater than your top bound, or else it would just produce an error, or give you the wrong answer, because clearly you can't have a lesser value be greater than obviously greater value. So we're just going to put this in case like they give us some weird numbers. So we put visible area. We're going to subtract our area of rectangle, or we're going to subtract the area of rectangle of our overlapped region. So if you didn't know, our overlap region is x1. It would be x1, y1, x2, y2. Basically 4 points to describe a rectangle. But this time it's going to be our left bound, our bottom bound. This is basically x1, y1, and then it's going to be our right bound and our top bound. So we're subtracting our overlapped area from the original area of the lawnmower billboard. So this should work. So it seems like we're done, right? No, we still have to return the visible area. All classes need a return statement, unless it's a void class. So now we're just gonna go up and we're gonna finish coding. And this is where we're gonna print out all our possible solutions. So if you forgot, we're gonna check if none of the corners are covered by a lawnmower billboard, or the cow feed billboard covers one corner of the lawnmower billboard, or if the cow feed billboard covers 2 corners of the lawnmower billboard. So what we're going to do is a series of if statements, checking if the cow feed billboard covers each of the corners of our lawnmower billboard rectangle. So we're just going to do a variable first, call it int covered. This is going to count the amount of times that we have covered, the amount of corners that we have covered using our cow feed billboard. So we're just going to declare the first if statement. If covered, if you forgot what covered does, it takes this point and it checks if it's within this rectangle. So if covered, x1, y1, or this the first point, and we're going to compare it to our cow feed billboard, or x3, y3, and x4, y4. And we're going to say covered plus plus. So what this does, it adds 1 to the covered count. So basically, if this corner is within the cow feed billboard rectangle, then we add 1. So that means if this is true, then one corner is within the rectangle, so covered equals 1. So if covered, we do another one. So this time it's going to be x2 and y2. It's going to be x3, y3, x4, y4. Covered plus plus. Alright, those are the 2 points that describe those are the original points that describe the lawnmower billboard. However, you may be a bit confused on which ones to put next. But if you go back to our graph, that's why it's always handy to have a nice graph workspace like this. We see that if this one is x1 and this one is x1 and y1 and this one is x2 and y2, then this one would be x1 would be x2 but also y1. So we're just going to put that exactly that, x2 and y1. And this one would be x1 and y2. So we can just put them in any order, and let's just do this. So if covered, we're going to do x1 and y2 first. x1, y2, and we're going to do x3, x3, y3, x4, y4. You can copy and paste this, but I'm too lazy. Covered plus plus. And our last one, let's just copy and paste this for the fun of it, for the memes. And it's going to be x2 and y1. So now we checked if all the corners are in the cow feed billboard. Now we just need to check how many there are. Using, as you can see from our workspace, if there's none, then we return the entire area. If there's one, then we still return the entire area. If there's 2, we use our visible area class. Let's do this. So we can check if covered equals 1 or covered equals 0. So basically what I'm saying here is if there's one corner or there's no corners covered, there's still going to be the entire area of the lawnmower billboard regardless. So let's do this. It's just going to be pw.println area of rectangle x1, y1, x2, and y2. Now comes the harder one. If covered equals 2, where 2 corners are covered, we're going to use our visible area class. So it's going to be visible area. It's going to be x1, y1, x2, y2, x3, y3, and x4, y4. So this is just very generic. It's just comparing the 2 rectangles and finding the visible area between them. In this case, the lawnmower billboard is described first, and that's exactly what we do down here. And we also have the pw.printout. Put that in parentheses. And let's just close both of them, pw.close and br.close, so they don't keep running and give us a bunch of weird errors. So pw.close and br.close. Alright, now it should work. It's completely, that's all we have to do. If we look back at our workspace, we already coded all of the cases. 1, 2, 3, 4. And we should be able to test it now. Let's go to the website. Let's choose our file. So I'm just going to locate my file. I'll be right back. Alright, welcome back. I have located my file. If you guys need help locating your file, or you have any other questions, please leave them out in the comments. I'll be more than happy to answer them. So we're just going to submit it. Oh, we have our and we have passed all the test cases. Alright, thank you guys for watching. I appreciate you, and I'll see you next time.